The linear regression model for the relationship between median income and poverty rate for the United States has the following residual plot. Now, in question 3, we had median income in the X position and poverty rate in the Y position. But for this question, we've reversed them so that poverty rate is now in the X position as the predictor and median income as the outcome predicted variable, which you can't see because we only have this residual in the prompt, but you know that poverty rate is in the X position. So median income must have been in the Y position. We're going to be asked to identify, based on the residuals, the point with the highest residual, what that means, the point with the least residual, and what that means, and whether or not a linear model is appropriate for these data. So I've switched these for you so you don't have to go back through and do it. Put median income in the Y, poverty in the X. Here's our regression line. The correlation coefficient is the same regardless of what's in what position. And we can lay in the residuals on this plot. And you can see some of these folks very close to the predicted value. This state with a poverty rate of 16.8 and a median income of 49,861 is very close to its predicted value. This state, poverty rate of 12.8 and a median income of 75,277 seems pretty far away from its regression line. But it's hard to tell, really, but you have a tab here that will give you your residuals plot. And that's what we see in the prompt. That's the residual plot that's in the prompt. But this is interactive, and so we can see better. If somebody is exactly on that line, their residual will be 0. And here's that point we saw, the poverty rate of 16.8. The true value of income is 49,861. The predicted value is 49,546, a residual of only $315 off. It was just a little tiny bit high, but it's very close. The XY coordinate for this person, this state, would be x equals 16.8 and y equals 49,861. And it's a little easier to see where our real residual is. This one, the poverty rate of 12.8 and a true income of 75,277, the predicted value was 61,681. The residual is 13,596. That's a lot different than the residual of $315. This residual is $13,596. Is there anything that has a bigger residual than this coordinate here? 13,596, 9,000, 10,000, 10,000, 5,800, 9,000. This is our biggest residual. This is the one we missed by the most. So let's go back and answer our question if we can. Identify the point with the highest residual. So it was this coordinate, 12.8 x 75,277y. That intersection gives us that dot, 12.8, 75,277. So we just put this in as a 12.8 for x, comma, 75277, I think is what it was. We'll double check. 75277, 12.8. 12.8, comma, 75277. That's the coordinate with the highest residual. That residual, as you remember, was $13,596 off. $13,596 off. Oops. What does this residual mean in context? The prediction equation underestimated the true median income by $13,596. $13,596. Identify a point with a residual close to zero. We already saw this point had the residual close to zero. It was only $315 off. So the coordinates for that point are poverty rate x, 16.8, income 49861. 16.8, 49861, if we can remember that long. 16.8, 49861. 16.8, 49681. Did I get that right? Let's find out. 49861. 49861. Oh, 861. Okay. Explain what this represents in context. So in context, that means that residual was only $315 off. It was a very close prediction. Prediction equation underestimated the true median income by only $315. That's a very close prediction. The residual is almost zero. Based on the residual plot, is a linear model appropriate for the data? The linear model for these data is appropriate based on several criteria, including the residual plot, which shows many values relatively close to the prediction line. How close? Overall, the coefficient of determination was 0.7 residuals, which indicates that a high degree of prediction was obtained.